I am a Polish physicist specializing in experimental particle physics. My native country is Poland, with mountains in the south, sea in the north, a rich culture and a glorious but also tragic history. My native town is Kraków, Poland's capital for many centuries, a town rich in cultural and scientific institutions. I early got interested in science, and it soon became clear that physics is my first choice. I was influenced by the biography of Maria Skłodowska-Curie, my compatriot and one of the best scientists in history. I studied physics at the Department of Mathematics, Physics and Chemistry of the Jagiellonian University in Krakow. This more than 650 years old university got several prominent students, but Nikolai Copernicus, the creator of the heliocentric system, is certainly the most famous one. The Institute of Nuclear Physics in Krakow, where I work, has witnessed all steps of my career from assistant to full professor. The choice of this institute was dictated by my wish to work in experimental particle physics, studying the most elementary components of matter and their interactions. Particle physics, complementary to astronomy, astrophysics and cosmology, brings information about the beginning, evolution and contents of the universe. While the last three disciplines try to reach the early stages of the universe, looking as far as possible in space, particle physicists try to recreate the conditions of the universe just after the Big Bang. Their basic tools are particle accelerators, pumping energy into beams of electrons, positrons, protons and diprotons or heavy ions. The Large Hadron Collider at CERN, famous due to the discovery of the Higgs boson in 2012, is currently the world's most powerful accelerator. However, fundamental questions remain. What is the nature of dark matter and dark energy? Why there is practically no antimatter in the universe? My scientific work has mostly been performed within large international collaborations. Altogether, I spent more than 8 years of my life in laboratories outside Poland, in Western Europe, USA and Japan. The most important for me was CERN and the almost 20 years of work for the Delphi experiment at the Large Electron-Positron Collider, the predecessor of the LHC. This work included the truly pioneering development of silicon detectors for very precise measurements of particle trajectories in experiments at colliders, nowadays a standard tool in all such experiments. For the last 15 years, I have been engaged in studies of neutrinos, tiny fundamental particles characterized by extremely weak interactions with matter. The 2015 Nobel Prize in Physics was given for the discovery of neutrino oscillations, considered to be a sign of new physics. Experiments with neutrino beam produced in accelerator centers and sent to huge detectors placed in underground laboratories hundreds of kilometers away are well suited for precise studies of this phenomenon. I have participated in 2 such experiments. Icarus, performed in the Gran Sasso laboratory and using the neutrino beam from CERN, has been already completed. The Tokaido Kamiokande experiment in Japan started in 2010 and still has a long time to go. My scientific work resulted in hundreds of publications supervising many diploma and PhD theses, elections to executive functions in experiments, and numerous invitations to scientific committees. The most important and prestigious was the election for the presidency of the CERN Council in the period 2013-2015. I was the first woman and the first physicist from a country not belonging to the same founders, given this function. Last but not least, I'm happy to be able to reconcile professional work with a successful family life.